on to line listing process. The line listing is one type of epidemiological database and is organized like a spreadsheet with rows and columns. Typically, each row is called a record or observation and represents one person or case of disease. Each column is called a variable and contains information about one characteristic of the individual, such as race or date of birth. Further on, description of line listing process. The first column or variable of an epidemiological database usually contains the person's name, initials, or identification number. Other columns might contain demographic information, clinical details, and exposures possibly related to illness. Mean. Mean is an essential concept in multiple fields. The mean is the average or the most common value in a collection of numbers. Actually, it is a measure of central tendency of a probability distribution along median and mode. It is also referred to as an expected value. It is a statistical concept that carries a major significance in finance and epidemiology. The concept is used in various financial fields, including but not limited to portfolio management and business valuation. One of the major uses of mean is to analyze the data gathered specifically in the field of epidemiology. I would like Anamika to continue.
Formula of mean. There are two versions of the mean formula in math, the sample and population formula. In each case, the process for how to find mean mathematically does not change. Add the values and divide by the number of values. However, the formula notations differs between the two types. Sample mean formula. The sample mean formula is the following. X is equals to sigma xn upon n, where x is the sample average of variable x. Sigma xn is equals to sum of n values. N is equals to number of values in the sample. Typically, the sample mean formula notation uses lowercase. Population mean formula. The population mean formula is following. Mu is equals to sigma xn upon n, where mu is the population average. Sigma x is equals to sum of n values. N is the number of values in the population. Typically, the population mean formula notations uses the uppercase letters. Using sample mean to estimate
Using sample means to estimate population means. In statistics, analysts often use a sample average to estimate a population mean. For small samples, the sample can differ greatly from the population. However, as the sample size grows, the law of large number states that the sample average is likely to be close to the population value. How to calculate mean? There are different ways of measuring the central tendency of a set of values. There are multiple ways to calculate the mean. Here are the two most popular ones. Arithmetic mean is the total of the sum of all values in a collection of numbers divided by the number of numbers in a collection. It is calculated in the following way. Arithmetic mean is equal to x1 plus x2 plus xn divided by n. Arithmetic mean may be misleading in the calculation of returns as it does not consider the effects of volatility and compounding producing an inflated value for the central point of the distribution. Geometric mean is an nth root of the product of all numbers in a collection. The formula for the geometric mean is the geometric means includes the volatility and compounding effects of returns. Thus, the geometric average provides a more accurate calculation of average return.
Median. The median is a middle value set of data that has been put into rank order. Similarly to median on highway that divide in road into two. The statistical median is value that divides the data into two halves, which one half of the observation being smaller than the median value and the other half being larger. Example of median. The median is also the fifth percentile of the distribution. Suppose you had the following ages in the years of patients with a particular illness: 4, 23, 28, 31, and 32. The median age is 28 years because it is the middle value, which two values smaller than 28 and two values larger than 28. Method of identify median. Step 1. Arrange the observation into increasing or decreasing order. Step 2. Find the median positions of the distributions by using the following formula. Middle position equals to number plus 1 divided by 2. Is the number of observation is odd, the middle position falls on the single observation. If the number of observation is even, the middle position falls between two observations. Step 3. Identify the value at the middle position.
Real.
હવે કટ મારી દે છે પીપીટી છે ને ઓલું કરવાની છે બદલવાની બીપી નો હમણાં વારો આવશે એટલે અત્યારે
અરે
અહીંયાથી
પણ બોસ અવાજ આવે ચોદ મારીને મને ખબર છે રિયલ તો બોલવાનું ચાલુ રાખને મને ખબર છે તું
આ લોકો મને ઊભું રાખે છે
રિયલ તારો અત્યારનો વારો આવ્યો છે બીપી ની સ્લાઇડ આવશે ત્યારે હું ચેન્જ કરનાર
Properties of median. The median is a good descriptive measure, particularly of data that are skewed because it is the center point of the distribution. The median is relatively easy to identify. It is equal to either a single observed value, if odd number of observations, or the average of two observed values. The median has less than ideal statistical properties, therefore it is often used in statistical manipulation and analysis. Moving to the next slide. Line listing of hepatitis A cases. County Health Department, January to February 2004. Mode. The mode is the value that occurs most often in the set of data. It can be determined simply by telling the number of times each value occurs. Consider, for example, the number of doses of diphtheria, pertussis, tetanus vaccine each of 17 2 years old children in the particular village received. Two children received no doses, two children received one dose, three received two doses, six received three doses, and four received all four doses. Therefore, the mode is three doses because more children received three doses than any other number of doses.
Methods for identifying the mode. Step 1. Arrange the observation into a frequency distribution indicating the value of the variable and the frequency with which each value. Step 2. Identify the value that occur most often, property and use of the mode. The mode is the easiest measure of the central location to understand and explain. It is also the easiest to identify and require no qualification. The mode is preferred measure of central location for addressing which value is the most popular or the most common. For example, the mode is used to describe which day of the week people most prefer to come to the influence vacancy clinic or the typical number of doses of DPT the children in a particular community have received by their second birth. As demonstrated, as distribution can have a single mode. However, a distribution has more than one mode if two or more value ties as the most frequency value. It has no mode if no value appear more than once. The mode is used almost exclusively as distributed measure. It is almost never used in statistical manipulation or analysis. The mode is not typically affected by one or two extreme values. Ratio data. Ratio data is a form of the quality data, like interval data, variable in a ratio data are placed at equal distance. Also, this scale features a true zero. However, unlike in the interval data scale, the zero in a ratio scale implies absence of variable for measuring. Leveling of measuring ratio data. There are four main levels of measuring statistics. Ratio data is the highest among the fourth measurement level, and it is the most complex measurement level. Also, ratio data features all the characteristics of the other three levels. The value can be categorized and ordered. In addition, they have equal interval, and the unique characteristic is that the value in the ratio level take on to 0. Now, Deep will presenting the PPT, and Bipin can speak.
Example of ratio data. The ratio scale is the preferred measurement level in natural and social.
ચાલુ કર ચાલુ.
Example of ratio data. The ratio scale is the preferred measurement level in natural and social science. Ratio data can be decreased four people are randomly selected and asked how much money they have with them. Here are the results: $20, $40, $60, and $80. Is there an order to this data? Yes. $20 less than $40 less than $60 less than $80. Are the difference between the data values meaningful? Sure. The person who has $40 has $20 more than the person with $20. Can we calculate ration based on this data? Yes, because $0 is the absolute minimum amount of money a person could have with them. The person with $80 has four times as much as the person with $20 data. Has all properties of interval data, such as data should have numeric values. The distance between the 2 points are equal, etc. But unlike interval data where 0 is arbitrary, in ratio data 0 is absolute. An excellent example of ratio data is a measurement of height. Height could be measured in centimeter, meter, inches, or feet. It is not possible to have a negative height when comparing to interval data. For example, the temperature can be 10 degrees Celsius, but it cannot be negative as stated above. Ratio data can be multiple and divided, and this is one of the significant differences between ratio data and interval data, which can only be added and subtracted. In ratio data, the difference between 1 and 2 is the same as difference between 3 and 4, but also here 4 is twice as much as 2. This comparison is impossible in interval data. Correlation and regression. Correlation and regression are the two most commonly used techniques for investigating the relationship between quantitative variables. Here, regression refers to linear regression. Correlation is used to give the relationship between the variable variance. Linear regression use an equation to express this relationship. Correlation and regression are used to define some form of association between quantitative variables that are assumed to have a linear relationship. In this article, we will learn more about these topics, are difference between correlation and regression, as well as see some associated examples.
Correlation definition can be defined as a measurement that is used to quantify the relationship between variables. If an increase in one variable causes a corresponding increase in another, then the two variables are said to be directly correlated. Similarly, if an increase in one can cause a decrease in another, or vice versa, then the variables are said to be indirectly correlated. If a change in its independent variable does not cause a change in the independent variable, then they are uncorrelated. Thus, correlation can be positive or negative or a zero. This relation is given by a correlate coefficient. Regression definition. Regression can be defined as a measurement that is used to quantify how the change in a one variable will affect another variable. Regression is used to find the cause and the effect between two variables. Linear regression is the most commonly used type of regression because it is easier to analyze as compared to the rest. Linear regression is used to find the line that is the best fit to establish a relationship between a variable. Now, correlation analysis. Correlation analysis is done as to determine whether there is a relation between the variables that are being tested. Furthermore, a correlation coefficient such as Pearson correlation coefficient is used to give a sign numeric value that depicts the strength as well as the direction of the correlation. The scatter plot given the correlation between two variables x and y for individual data point as so below. Now, regression analysis. Regression analysis is used to determine the relation between the two variables, such as that the value of the unknown variable can be estimated using the unknown of the known variable. The goal of the linear regression is to find the best fitted line through the data point. For two variables x and y, as you can see in the chart, the regression analysis can be visualized as follows. Thank you. Thank you everyone for your contribution.